product. These are just the formula you see here. Here I won't comment here because I already explained this in another video. It's like just dot product and some formulas that you can have, cross product and some formula and how you can solve this matrix. Okay, and then this is a scalar times one, and then if you continue, you will see this is like just dot product giving you those value there, and cross product, some rules we use for the unit vector, what you can get here. Okay, these are just Cartesian points based on P. This time around, just name them as P. So you could see the name, it's P. So this is what we have. Put it together in order to get P. So P, normally we use this one as AX, but now since we're working with P, not with A, so that's why you see this, we get to this form. So this should be Y, J plus P, Z, K. It's not even P, so since I'm using A, so let me also correct this one. This one should be not be X, it should be Y. So this is what we have here. Okay, it's just similar to what we saw before, and this is some Cartesian point you can have. Okay, and then if you go further, this is what we see on projection of a vector. Some calculation can perform if we project those two vectors. Because I'm not going to go into details about this because you're not going to need it. Okay, and some formulas that you should know. Force. Okay, we're going to see some application of these formulas, but we're not going to go into details. Okay, for now I'm just giving you a div of a force, basically it's divergence of a force. Okay, this is vector times that force, and this is how you could represent the divergence. And then the same goes for this form, and then this is F. Okay, and then if you have to represent them, that's what you get there. Now we go for a curl, basic of curl. This is an example of basic of curl. You get the matrix. Okay, since we're using a cross product, and then from there you can solve for the equation. And then we got the gradient. We're not gonna go into details, but we see some application of the gradient for formulas. Okay, these are just example of gradient. And then variation times F limit. This is just gradient. And then we have a function of cos. Okay, this is an example of a function of cos, integral. And the rest is just a proof of cos divergence. That's how we can apply the proof of, for you to get the total volume, and then a function of Stokes Theorem. So it's going to cover this. And here those formula are very important. We're going to use them. We're going to move to the example phase later on. So this is the last point that you need to cover. So cylindrical to Cartesian conversion. This is the formula we're going to use since this is a 3D. AZ, AY, AZ, AX. And then it's the same as this form here, but we're going to use only what you see on top here. Let's make sure. And then this is cylindrical conversion. You're going to make use of these rules, Cartesian to cylindrical conversion. So you can see Z, X, Y. So this is when you have a 3D, and the same here, 3D, Cartesian to cylindrical. This is the form you can get. I'm going to make use of those formula, and here it's just the representation of cylindrical, rectangular, and then spherical. So you can see, and the spherical is something, it's not, it's actually, see that's spherical, and then cylindrical is something like this. We got the cylindrical here, and then rectangular, it would be just square or rectangular or something like that. Okay, there you have it.